Welcome to The Explainer. Today, we're going to crack the code on the DevOps interview. We've gone through hours and hours of tutorials to pull out the key concepts and the powerful, concise answers you need to absolutely nail that interview. So if you're trying to land one of those top-tier DevOps or SRE roles, you know the deal. You're facing questions that span this entire massive landscape. One minute, they're asking about low-level networking. The next, it's all about high-level architectural strategy. It's a lot. So the big question is, how do you possibly master all of that and walk in ready to deliver those sharp, confident answers? Well, that's exactly what this explainer is for. We've laid out a guide to the most critical concepts to give you the clear answers that interviewers are actually looking for. Here's how we're going to tackle this. We're breaking it down into 4 key areas. We'll start with the foundation, cloud networking and security. Then we'll build on that, talking about why we even need container orchestration. From there, we'll dive deep into core Kubernetes concepts, and we'll wrap it all up with essential DevOps strategies. All right, let's dive right in with Section 1, Cloud Networking and Security. This is the bedrock. Seriously, if you get this part wrong, it doesn't matter how great your application code is, it's just not going to work right. Okay, this is a classic. If you're in an AWS-focused interview, you're almost guaranteed to get some version of this question. What they really want to know is, do you understand how to route traffic correctly and efficiently for different situations? So let's just break it down. The core difference is pretty simple when you think about it. The application load balancer, or ALB, works at layer 7. You can think of it as the smart one. It understands HTTPS traffic, it can look at the URL path, /images or /API, and route traffic based on that. The network load balancer, or NLB, is a completely different beast. It's all about raw speed at layer 4, just blasting TCP and UDP packets through as fast as humanly possible. And really, it all boils down to the use case. You have to pick the right tool for the job. So if you're building something where every millisecond counts, think online gaming, live video streaming, anything that uses UDP, you need that raw speed. The network load balancer is your only real choice. For just about every other modern web app that needs that smart path-based routing, the ALB is going to be your go-to. All right, let's pivot a little bit and talk security. Now, if there is one single rule you need to burn into your memory about AWS IAM, it is this. An explicit deny always wins. You could have a dozen policies giving a user an allow to do something, but if there is just one policy with an explicit deny, it's game over. The deny overrides everything. It's the final word. In an interview, you're probably going to see a policy snippet that looks just like this, and you need to be able to instantly spot the 3 key parts. You see the effect is deny. The action is S3 star, which means all S3 actions, and the resource is that specific S3 bucket. So what does this mean? It means no matter what other permissions a user has, this policy blocks everything on that bucket. That rule is absolute. Okay, that's our foundation. We've got our networking and security locked down. So let's build on that and move into our next section, which is all about how we run our applications on top of this infrastructure, especially at scale. This is one of those fundamental why questions. We can all run a Docker container on our laptop, but in the real world, in production, just running a single container isn't enough. When an interviewer asks this, they're testing if you understand the real-world limitations of just using Docker by itself. See, running Docker all by itself in production, well, it creates some major headaches. First, you have the single host problem. If that one machine dies, poof, all your containers are gone. Then there's the auto-healing problem. If a container crashes for whatever reason, it just stays dead. A person has to go in and manually restart it. And finally, the auto-scaling problem. Imagine it's Black Friday and your traffic spikes. You've got to manually spin up more containers. None of this is sustainable for a real business. And this is precisely the set of problems that Kubernetes was born to solve. It's a container orchestrator. Its entire job is to automate all of that manual, painful work. It handles deploying your containers across a whole fleet of machines. It automatically restarts them if they fail, and it scales them up or down based on real traffic. So how does Kubernetes actually pull this off? What's the magic here? Well, it all comes down to a few core foundational concepts that you have got to know inside and out. So let's break them down. All right. Here's a detail that can really trip people up. In Kubernetes, your containers don't just run by themselves. They run inside something called a pod, and every single pod gets its own unique IP address. But And this is the key, that IP address is ephemeral. It's temporary. So when a pod dies and Kubernetes automatically restarts it, the new pod gets a brand new IP. So what happens if your front end was trying to talk to the back end at that old IP? The connection is broken. And the elegant solution to this whole messy problem is the Kubernetes service. You can think of a service as a stable abstraction layer that sits right in front of your pods. It gives you a single virtual IP address that never, ever changes. All of your other applications talk to the service's stable IP, and the service intelligently routes that traffic to the healthy pods behind it, automatically keeping track of their new changing IPs. And what's cool is you have a few different flavors of services to choose from, depending on what you need. The default is called cluster IP, and as the name suggests, it's only reachable from inside the Kubernetes cluster. Then you have node port, which exposes your application on a specific port on all of your machines, great for quick internal access. And finally, you have a load balancer, which is the big one. It hooks directly into your cloud provider, like AWS or Google Cloud, and automatically provisions an external load balancer to make your app available to the whole world. All right, so we've got our infrastructure, we've got our orchestration. What's next? Well, we have to talk about the code itself. The developer workflow that feeds this entire system is just as crucial. Here's another classic, high-level question. And listen, this one isn't about a single right or wrong answer. It's a test to see how you think. They want to know if you can reason about things like team structure, project dependencies, and different development life cycles. So the absolute best way to answer this, start with these two magic words. It depends. Right away, that shows the interviewer that you understand this isn't a black and white issue. You're not just repeating something you read in a blog post. You understand there are trade-offs. So, what does it depend on? Well, a monorepo, where all your code for every service lives in one giant repository, can be fantastic when you have a lot of projects that depend on each other. It makes managing shared libraries and versioning way easier. But a multi-repo approach, where each service has its own repository, is often better for large organizations with separate teams that need to move fast and have clear ownership. A good rule of thumb: if your teams are spending more time just coordinating releases with each other than they are writing code, that might be a sign that a multi-repo setup is causing friction. Okay, so let's pull all of this together into a quick interview cheat sheet. Number 1, be ready to compare and contrast core concepts, like the ALB versus the NLB. Number 2, know the hard rules, like the fact that an IAM deny always wins. 3, don't just explain what a technology is, explain why it exists. Why Kubernetes over just Docker? 4, understand how specific components, like a Kubernetes service, are designed to solve very specific problems. And finally, number 5, be ready to talk about the trade-offs of high-level strategies, like monorepo versus multi-repo. And that really brings us to the final big picture question you should be thinking about. Knowing all these individual pieces is fantastic, it's crucial. But the real challenge, and honestly what the best companies are really looking for, is your ability to see how it all fits together. How do you assemble all these components, the networking, the security, the orchestration, the code strategies, to build a system that isn't just working, but is truly resilient? That right there is the heart of DevOps and SRE.